Thank you very much. Thank you. Okay, so I'm Matt Cox. I'm a software engineer with Guestline. Guestline is a company that make property management software. That's software used primarily by hotels to help manage with the day-to-day running of their hotels. And I work primarily on the front end, and we've been playing around with this pattern that we're calling event-driven front ends. This is something that we think has some interesting benefits and thought worth sharing. So, the what, the why, and the how, although I should say not necessarily in that order. So, first, some caveats. So this whole thing is going to exist within an event-driven architecture. I don't mean browser events, I know I'm talking about front ends here, but so not click or mouse over events, but business events. So it's reservations created, products sold, that sort of thing. What we're going to be doing ultimately is bringing those events right down into the browser. And we're going to be asking a lot of the browser, we're going to be pushing the browser hard, sometimes close to breaking point. So this is not a pattern that's going to be applicable everywhere. It's best if your site is used by returning users, probably authenticated returning users. As you'll see, there's going to be a large first-time load, and you'll see that later. So yeah, invested in your product, returning users is going to get the most out of it. I don't really see this working on a sort of general public-facing website where milliseconds really matter, and internet connections are flaky. Lastly, we're still very much experimenting with this, so don't take this, despite me speaking with some further about it, don't take this as a guaranteed recommendation. We're still working out and finding out if it's a good fit even for us. Okay, so why do this? What's the benefit? I'm going to start with an example, and this example is going to sort of follow a student talk. So building out a reporting system within our property management system, the PMS, which is, here it is. As I said, our customers are hotels. Here are 3 of them. Let's focus down on one of them there, and let's meet the revenue manager in this hotel. Now, she would like to get a sense of how her hotel is performing, and one of the metrics she'll use for that is how full up her hotel has been over the last month. So we call that occupancy, and it's a key metric for her. So what she'll do is she'll navigate to the web app, our PMS web app. She'll go to the reporting section, and she'll click on the this month occupancy report. So now, as developers, let's think how we might build that. Probably we'd have some kind of back-end service. I've said we're in an event-driven architecture here, so we're going to be bringing events through, processing them to some extent, and then storing them probably in some kind of persistent storage. Along comes our client, our browser. We're going to want to communicate up to that back-end service, and surely we're going to be using some sort of API. We'll be calling it endpoints, and our API service there will do some sort of work, getting data out of the database and returning whatever it is the front end needs to render that chart. Nothing wrong with this, perfectly usual and perfectly fine way to work. This is what we did previously with our reporting system, with a slight caveat, slight difference where we had a sort of nightly run where we populated a distributed Redis cache, and that was what the client used to get its data. The problem was this was very expensive, and what we had to do to even make those costs in any way manageable was reduce the data size down considerably, which was a frustration for our users who quite understandably wanted access to all of their data, and we were really only providing them a window on it. So that's sort of the first problem we're trying to solve here, really, is the high cost of that infrastructure. So the next thing to think about is let's try and now develop a new report. So how about an occupancy forecast report? This doesn't exist yet. We need to do work on the back end. It doesn't have maybe not even ingesting the events it needs perhaps to produce that report. So we're going to be developing this in the front and the back. Let's say perhaps our organization is structured like this, where we have a front-end team responsible for those front-end elements, a back-end team for the back-end bits. So now we're developing on multiple code bases across multiple teams. And our development sort of flow might look a bit like this, where we are the front-end team, we're the ones that want to develop this, so we know we're going to need to ask some development work from the back-end team, which means we'll need to fully scope out our idea so that we know what to ask those guys. They'll take it, they'll need to fit it into their sprint schedule, they'll build it and test it, pass it back to us. We might finally need to tweak it a little bit, we'll pass it back to them. Finally, we get to sort of develop against it, we'll release it, and finally get to the point where we can get some feedback from our users. At which point we iterate and the process starts again. I might have exaggerated the pain of this a bit, but I think it is less than perfectly agile and is a little bit painful. So we'd like to solve that problem too. So, how are we going to do that? Well, we're going to bring that data right down into the client, right down into the browser. Then instead of calling that service, we can just run the necessary work in JavaScript in the browser on that data. So this is brilliant for fast, agile, explorative development. We're going to use JavaScript, as I say, to just do work on that database. And now our development cycles might look a bit more like this. We can just build, release, get feedback loop. I haven't even included the scope step here, because when we're really exploring mode, we don't want to overplan, we just want to start. Having a single code base with direct access to the raw data gives us that power. And that's really the core of this pattern that I want to get over today. The freedom to try things, iterate fast, and throw stuff away if it doesn't work. One code base, one team, sometimes just one developer, experimenting in the wild. It's agile, fast, and honestly, it's a real joy to work this way. It's really fun. So, without that back-end infrastructure, we don't have that associated cost, of course. As I've shown, I think the development cycles can be much leaner, much faster. A couple of other benefits potentially come along for the ride, which is that we open the door to some offline capabilities and maybe even some local first practices. It's not something we've actually honestly explored yet, but I think this does become possible. So what is it we're actually going to be doing? As I've said, we're in an event-driven microservices architecture, so we've got events flying around our system, business events, reservation created, etc. We have a multitude of services taking in those events and doing whatever it is they're doing with them. Here's one of them here. It's taking in an event, doing some processing, and updating some state that it manages. And probably it's going to persist that state in some permanent way, probably a database. Now, a common but not ubiquitous pattern within event-driven architectures is something called event sourcing. So this is where you take your events and you append them onto a log file and store them in perpetuity. It's a bit like, I guess, an accounting ledger, where you add financial transactions onto the end of your ledger. You would never edit those line items or remove them. If you made a mistake, you would just add another line item to correct the mistake. And in that sense, they're sort of immutable. And similarly, the events as they exist in the event log are also immutable. Here's a kind of closer look. So here's our maybe reservations event stream, event log file. So we've got our events as they come in, we just append them on the end there. And there are multiple events per entity, potentially. I've kind of color-coded them a bit here. So maybe let's look at this blue one. This is, let's say, a new reservation. This is the create event. So the user created a reservation. But later on, we have this update event. Perhaps they wanted to extend their stay. Here, maybe they, changed their room type, added breakfast, You know you have an event source system if you have your service, you have the associated state that it manages. If we kind of blow up that state, it disappears. This could potentially be a pretty catastrophic situation, but in an event source system, we can take the events from the log, feed them into our service in order, and the service should be able to reconstitute its state. If you can do that, then I think you have an event source system. It's important to say that the service can't rely on any other external inputs. It has to be purely from the state there. But if you can do that, then yeah, you have an event source system. There are quite a few benefits to this, like great for debugging. You can work out exactly why your state got into the state it did. How about historic state? You want to know what the state was at a particular point in history. Or how about a memory-only service? It's ephemeral, it just exists in RAM. You spin it up, you pass it the events, it produces its state, and then dies. And in fact, this is kind of the key point. The event store allows you to treat that state as entirely and trivially reproducible. So why not do it in the browser? We can fetch our events from the event store, process them in JavaScript, and create our state in the browser. Then you can interrogate it to create your data models on the fly, all in the front end. The problem, of course, is that this is potentially enormous, and we run the risk of completely overwhelming the browser. So we need a way to kind of bring down that size. One very obvious and extremely necessary thing we'll need to do is we'll need to partition our event store by customer. I mean, if nothing else for privacy concerns, clearly. But we'll have our event store here, and some, as I haven't said yet, but very cheap cloud storage like an Azure Blob or AWS S3 bucket. And we'll have like directories for all of our event streams. We'll have also directories for all of our customers. And then here, for example, is the reservations event log for customer A. But the other thing we're going to do, which is another quite common pattern in event store system, is something called snapshotting. So again, here's a closer look at that ginormous event log for customer A. Here are all the events that came for Monday, all the ones for Tuesday. And, oh yeah, for the sake of the argument, let's just say this is the beginning of time. It's where the event log, where the reservations stream started. So what we're going to do is on Tuesday morning, we're going to process all those events that came in on Monday to produce a new snapshot file that's going to kind of exist next to the event logs. And the way, so snapshotting is where we condense each entity, so each color, each reservation, down to a singular item, right? The event log will probably contain multiple items for each entity, but the snapshot will contain only one. So if we were trying to snapshot the blue event stream here, the blue entity, sorry, in our case it's actually really easy. We use each event carries the full state of the entity in our system. I think that's called event carried state transfer, to be geeky about it. So all we need to do is just take the last one. So it's actually a super easy process. And then we do the same thing for all the other entities, and we produce this snapshot file. And then on Wednesday morning, we do the same thing for our previous events. By the way, I'm doing this on a daily schedule. It doesn't necessarily need to be that, but that's what we've chosen. And we take our previous snapshot and condense it next to the previous event logs to produce Wednesday's snapshot. And we end up now with an event store that looks like this. Within each customer directory, we have a date, and with each one of those, we have the snapshot that was produced that morning and the day's event log. So that huge event log is now split into a daily event log. This snapshot can get very large, but it's going to be very much smaller than the entirety of that enormous event log. So now, finally, we're getting to the browser. Don't worry, I'm not way over. But what we're going to be doing is bringing that data from the event store down into the browser and storing it in a SQLite structure. I don't really have time to go into why SQLite was the best idea for us, but it certainly was the right choice. Then we were able to just use JavaScript to write queries, to develop our new report, to write SQL to interrogate that database. And this is where we wanted to get to, basically. There is one obvious problem here, which is that at the moment this SQLite database exists just in RAM. So when the session ends, it's going to die. The user's going to come back to the page and have to download all that data once again. So that's not good. So what we're going to do is we're going to store that SQLite data in the Origin private file system, the OPFS. I don't know if you've used this before, but it's just another storage mechanism available to the browser. Disk storage, much like local storage, cookies, or IndexedDB. It's origin scoped and sandboxed, provided access to the OS's file system, and it's perfect for storing SQLite database. So that's what we're going to do. And this actually is all made very easy, by the way, by a package from SQLite.org, so an official WebAssembly build of SQLite, and it's available on NPM. So now when the user arrives at the app, they're going to do an initial download. Perhaps this is their first visit. So they're going to have to download the big snapshot and the event log and pipe it through the browser and store it in the OPFS there. This is a big operation, many megabytes coming off the network, potentially decompressing to many gigabytes potentially, and potentially millions of events. So this is probably going to be many minutes. The next day, however, we're not going to need to download that snapshot. We just can get the latest event log, and things are much faster. And in fact, if we come back that same day, we can use like an HTTP range request to literally just get the latest events. So that's a clear use case for persisting data on the OPFS, but another one is memory concerns that the browser has. The browser has a limit to how much data can be stored in memory. Typically, I think that's about 4 gigabytes for modern desktop browsers, but that is not reliably true, and it's also not knowable in code. And so we run the risk of crashing the browser with a horrible out of memory exception. And as far as I'm aware as well, that is also uncatchable in code. And some of our customers' data, uncompressed, is in excess of that 4 gigabyte limit. So that's definitely another reason to use SQLite in the OPFS. We just need to write sensible queries and sensible select statements, not bring too much into memory, so page the results if necessary. The amount of data you can store in the OPFS is really kind of only limited by how much space you have on disk. That's a big caveat to that, which is that when the session ends, if you're running low on disk space, the browser or the operating system, I'm not quite sure which, may decide that actually, no, I'm not going to keep that, it's not enough room, and it gets evicted. And so the next time the user comes to the site, it has to do that big download again, and that's definitely a problem. One last thing to say here is that quite clearly we're doing a lot of processing, and we want to protect the main thread from all that work. So we're going to be doing this in a web work. We're going to be doing the fetching and the storing, and actually the processing, all within that web worker, just to protect the main thread. Final thoughts. So I think this is a very efficient use of resources. We get rid of that backend service entirely and save all that cost and infrastructure. It's really empowering for front-end devs. As part of the reporting team, I personally have an interest in data science, and so it's really nice to be able to play with that raw data. It empowers us to dream up wacky ideas, as we have access to everything we need to do it in that one codebase. We can get it out there, put our ideas in front of users for fast feedback. So it's really great for that explorative development, which I think ultimately leads to better products and happier customers. So I'm not saying this is all about dev experience. I think this does have the ability to produce better products. There is the case that there's a poor experience for some users, eviction being the main case in point really. If they are running low on disk space, they do run the risk of having that eviction, and that's definitely a degraded experience. Also, lower spec machines, so we find that 16 gigabytes of RAM seems sufficient, 32 gigabytes better, but 8 gigabytes with a large data set is quite painfully slow. So again, some issues there. Security concerns, well, the data certainly is sensitive, but it is completely owned by the customer. They are stored on their hard drive, they store sensitive data on their hard drive. What we do is we just very explicitly ask for opt-in. We say what we're storing, and we ask for that very explicit opt-in, and they can opt out at any time and easily remove the data. And this is the last point. So yeah, mobile networks, you wouldn't want to do that massive load probably on a mobile network. And as far as I know, it's hard to reliably detect if you are on a mobile network, so that's a bit of a challenge as well. As far as I'm aware, all the APIs work on mobile browsers, but I actually haven't properly tested this yet. So sorry to end a bit anticlimactically, over time. So thank you for listening.
Well, now we have time for one question.
Thank you. That's a really interesting talk. I have two-part questions. The first question is, we haven't mentioned how much is normally the payload that you currently send to the customer on the browser. I would like to know a little bit more about what size are we talking about, transfer over where.
It would be less than 500 meg, probably in the region of between 20 and 100 meg. Generally, that's compressed, so that will decompress to into the gigabyte range. But it's so customer dependent. Like, ideally, the data will be very nicely split for the customer. We'll probably use that. And so we have probably about 80-20. 80% is probably under 20 megabytes at this time. And especially with OPFS, it's a lovely experience. For 20% of customers, the data size is continually larger.
And the second part of that question is, right now it seems that you are segmenting the data based on the specific user experience. But what happens if the user needs to access overall data? Will you actually have the ability to do that at this point in this architecture? For example, if you wanted to compare your property with other property to see if your property is doing better than your property. colleagues, will you be able to do something like that? With this architecture, will be possible?
Yeah, I mean, this particular architecture wouldn't be suitable for comparing properties that you don't own with yours. You wouldn't be able to access that data, no way. We do actually have a solution for customers that have multiple properties, which gets more complicated with multiple properties. I'm definitely not going to go into that. But yeah, if it's not your data, then it's not a feature for us.
Gotcha. Thank you.
100% secure. I love it. All right, thank you everybody. Have a great